Dear students, in this module we shall discuss the action potentials. Action potentials are the type of signals that neurons use to send information along the nervous system for long distances. The action potentials are brief but large changes in membrane potential that are propagated along the axon without decrement, that is, कम हुए बगैर पूरी इंटेंसिटी के साथ equally move करती है. The action potentials are very important as they control the effector responses. They control the activation of voltage-gated ion channels. They control muscle contractions and they also cause exocytosis. In fact, action potentials are responsible for every sensation, every memory, every thought, indeed every impulse. अब हम एक्शन पोटेंशियल की फेजेस, जिन फेजेस में ये एक्शन पोटेंशियल मुकम्मल होता है, ये तकरीबन 5 स्टेप्स में मुकम्मल होता है. द फर्स्ट स्टेप इज द स्टिमुलेशन. सेकंड स्टेप इज द राइजिंग फेज in which depolarization occurs. The third phase is the peak phase. And then fourth is the falling phase in which repolarization occurs. While the last phase of action potential is the undershoot, also known as after hyperpolarization. हम इन फेजेस को बारी बारी डिटेल के साथ स्टडी करेंगे. सबसे पहले हम स्टिमुलेशन की बात करते हैं. When a stimulus is received at axon hillock, axon hillock वो जगह है जहां से एक्शन पोटेंशियल जनरेट होता है, and this place has voltage gated ion channels in it. So the stimulus causes the sodium channels to open in the neuronal membrane. When sodium channels open, sodium ions start to influx. This results in change in membrane potential locally, which is called depolarization. As a result of depolarization, membrane potential becomes positive, relatively positive. Then a depolarization of about -55 to -30 millivolt is known as threshold. That can trigger an action potential. If the intensity of the stimulus is less than this threshold, it is called a subthreshold. It also causes depolarization, but these depolarizations cannot initiate an action potential. After a threshold has acted on the axon hillock, sodium ions start to enter and membrane potential becomes less negative. This causes more sodium channel to open, causing an even greater influx of sodium ions. यहां पर पॉजिटिव फीडबैक होता है, जिसकी वजह से सोडियम आयंस जो एंटर होते हैं उतने ही ज्यादा सोडियम चैनल्स ओपन होते हैं. चूंकि इस वक्त तक अभी पोटाशियम चैनल्स बंद होते हैं, इसलिए सोडियम करंट डोमिनेट करती है और मेम्ब्रेन पोटेंशियल पॉजिटिव होना शुरू हो जाता है. द सोडियम चैनल्स बिकम मैक्सिमली ओपन. एट दिस स्टेज द positive feedback slows down. The membrane potential reaches a maximum, that is close to the sodium equilibrium potential of positive 55 millivolts. At this stage, further depolarization stops and it is known as the peak. ये एक थोड़ा सा टाइम जिस दौरान में मेम्ब्रेन पोटेंशियल पॉजिटिव रेंज में रहता है, इसे हम ओवरशूट कहते हैं. इसके बाद पीक फेज के बाद फॉलिंग फेज शुरू होती है. मेम्ब्रेन दोबारा से रिपोलराइज होना शुरू हो जाती है. the voltage-gated sodium channels start to close. So no further influx of sodium ions occurs. Voltage-gated potassium channels start to open. As a result, potassium ions start to outflow. जब potassium ions का outflow शुरू हो जाता है तो membrane दोबारा से polarize होना शुरू हो जाती है and this continues towards the potassium equilibrium potential of minus 58 millivolts. Result is repolarization, that is reversal of membrane potential. However, the membrane repolarization initiates closing of potassium channels. जब potassium channels close होना शुरू होते हैं तो repolarization का process slow down होता है, लेकिन potassium channels delayed rectifiers हैं, ये देर से activate होते हैं, इसलिए potassium ions का outflow जारी रहता है. As a result, the membrane potential dips even below the normal resting membrane potential. This means that membrane has become hyperpolarized. This brief hyperpolarization is known as undershoot or after hyperpolarization. It persists till the potassium permeability returns to the normal value.